Humans have established a permanent settlement on the moon, designed to be a hub for research, exploration, and sustainable living. Strategically located at the moon's south pole, this fully operational lunar base benefits from near-constant sunlight and access to water ice, essential for life support, energy generation, and further exploration. The site's unique position also minimizes the extreme temperature fluctuations found elsewhere on the moon, creating a stable environment for habitation and supporting ongoing activities by both astronauts and robotic systems. Expansion on the moon is being guided by superintelligent AI, which continuously analyzes data to optimize infrastructure development and resource allocation, ensuring efficient and sustainable growth. Extensive mapping probes have surveyed the lunar terrain, enabling the design of well-planned roads and cities to support future generations. Meanwhile, autonomous robots equipped with general intelligence are actively constructing additional facilities and essential infrastructure, accelerating the expansion of human presence on the moon. Lunar habitats are constructed using advanced 3D printing techniques that combine moon dust with synthetic compounds, creating structures that shield colonists from radiation and provide comfortable living spaces. Scientists address the challenges of lunar dust with electrostatic dust shields and filtration systems to protect equipment and habitats. Additionally, large transparent domes with radiation shielding are being built, creating Earth-like atmospheres for human life. These colonies use closed-loop systems to extract oxygen from lunar soil and ice, recycle air, and maintain pressure to support the community. A network of communication satellites connects the moon with Earth, providing real-time communication capabilities. This allows for seamless data transfer and even remote control of lunar robots by operators on Earth, ensuring continuous collaboration between the two worlds. Ice deposits near the lunar poles are being mined to provide water for drinking and agriculture, and are split into hydrogen and oxygen for rocket fuel, which will be critical for future missions to Mars and beyond. Food production on the moon has become essential, as transporting food from Earth is not sustainable long-term. Colonists are using hydroponics, aquaponics, and vertical farming to grow food locally, and while efforts are underway to cultivate crops in lunar soil, additional nutrients and organic materials are still required to support a sustainable agricultural system. The moon has become a bustling center of activity, where lunar colonization is no longer a distant dream, but a thriving reality. Space tourism is a booming industry, with companies offering luxury trips to the moon. Visitors can experience low-gravity sports, walk along the lunar surface, and take in the breathtaking view of Earth rising above the horizon. To thrive in the moon's harsh environment, humans have begun using advanced cybernetics and genetic engineering. Enhancements such as increased lung capacity to process lower oxygen levels and cybernetic limbs designed for enhanced strength and durability have made it possible for lunar colonists to work more efficiently. The moon is becoming a crucial spaceport for launching missions to Mars and beyond. Its low gravity and strategic location allow for dramatically reduced fuel costs compared to Earth-based launches. A transformative advancement in this effort is the 3D printing of rockets directly on the moon using local materials. This breakthrough makes rocket production faster, more scalable, and far more cost-effective, reducing dependency on Earth-based launches. On the moon, humans can seamlessly communicate with people on Earth through advanced virtual environments and immersive holodecks, creating the sensation of being together despite the vast distance. These technologies enable face-to-face conversations, collaborative workspaces, and even social gatherings that feel as if they're taking place in the same room, bridging the gap between lunar settlers and Earth. Additionally, humans interact with a wide array of conscious AIs within these virtual spaces, consulting them for knowledge, insights, and companionship. These AIs, some of which have developed unique personalities and specialties, are integral to daily life on the moon, enhancing both productivity and the social experience for lunar residents. Scientific discovery continues to flourish with the construction of the Lunar Crater Radio Telescope on the far side of the moon. The moon's lack of atmosphere, combined with its shielding from Earth's radio interference, gives this massive telescope an exceptionally clear view of the cosmos, allowing scientists to study distant cosmic phenomena with unprecedented clarity. Innovations in agriculture are also changing life on the moon. Long-term experiments with lunar soil have led to partial terraforming, enabling specially bioengineered plant species to grow directly on the moon's surface. These green areas provide oxygen-rich domes where colonists can experience outdoor nature on the moon for the first time. To protect critical infrastructure, guards equipped with conventional firearms are stationed at key lunar facilities. Despite the moon's unique conditions, these firearms remain highly effective, with lower gravity providing them even greater range than on Earth. The moon has transformed into a sophisticated environment where permanent human habitation is both comfortable and practical. Engineers have built rotating habitats that simulate Earth-like gravity, significantly enhancing the health and well-being of lunar residents. These habitats allow for extended stays and support larger populations, making it possible for humans to live on the moon for years without the detrimental effects of low gravity. Lunar colonies have also become renowned for their cutting-edge gene therapy centers. Leveraging the unique conditions of the moon, including low gravity and increased radiation exposure, scientists are able to accelerate biological research, yielding therapies that are impossible to develop on Earth. These advanced clinics offer treatments that enhance human longevity and help individuals adapt to the moon's environment, effectively making the lunar colonies a center for medical tourism and a hub for groundbreaking biological advancements. Healthcare on the moon has also advanced considerably with the introduction of surgery robots that can perform complex medical procedures. These robots ensure that colonists have access to life-saving surgeries and advanced medical care, despite their distance from home. Mining operations are thriving on the moon, extracting valuable resources such as helium-3, which is vital for advanced nuclear fusion, and rare earth elements critical for modern technology. These mining ventures have become the backbone of the lunar economy, fueling energy needs on Earth and pushing forward technological development. However, the wealth of resources available on the moon is also creating tensions among nations. As countries establish their claims over territories rich in rare minerals and water ice, disputes are beginning to escalate. There is growing concern that these conflicts could boil over into a full-scale lunar war as nations compete for control of these valuable assets. The prospect of a lunar conflict introduces significant geopolitical complexity to space colonization, highlighting the need for international agreements to prevent hostilities and ensure that the moon remains a place of peaceful exploration and cooperation. The moon is home to the first permanent lunar cities, where hundreds of humans live alongside robot companions. These settlements feature self-sustaining habitats powered by solar energy and advanced life support systems. The cities are bustling hubs for scientific research, space tourism, and off-world manufacturing, marking a major milestone in human civilization. Robots assist in daily life, handling both mundane tasks and complex operations, ensuring lunar living is efficient and comfortable. Self-driving vehicles are common on the lunar surface, transporting goods and passengers safely. Efficient transportation fosters connections between settlements, contributing to the cohesion of the lunar community. As the population grows, lunar governance is evolving through international coalitions and private companies, creating a legal framework for trade, property rights, and activities. This sparks debates on sovereignty, space law, and settlers' rights. Lunar manufacturing is taking off, using local materials to produce goods that are costly to make on Earth. These capabilities reduce the strain on Earth's resources, and the moon's low gravity makes production more efficient. The development of lunar industry lays the foundation for an interplanetary economy where resources are shared across multiple celestial bodies, bringing humanity closer to a spacefaring society. Life on the moon has developed a rich cultural and creative landscape that sets it apart from life on Earth. Artists and creatives living on the moon have begun producing new forms of art, music, and entertainment that are directly influenced by the moon's low gravity and stark otherworldly landscapes. The reduced gravity allows for fluid, dynamic movements that are impossible on Earth, inspiring unique dance styles and performance art that seem almost weightless. And musicians incorporate the moon's silence and resonance into their compositions, creating hauntingly beautiful pieces that capture the essence of life in space. Travel between the moon, Earth, and beyond has become significantly faster, thanks to spacecraft powered by antimatter propulsion and nuclear fusion. These technologies have drastically shortened the duration of interplanetary trips, making the moon more accessible than ever before. The ability to travel quickly not only strengthens the connection between lunar colonies and Earth, but also accelerates the pace of space exploration and settlement. Journeys that once took days or weeks can now be completed in mere hours, enabling a continuous exchange of people, goods, and ideas between the moon and other celestial bodies. Replicators have become a cornerstone of lunar life, making colonies increasingly self-sufficient. These advanced machines can create essential products on demand, from tools and equipment to food and household goods. By using locally sourced materials, replicators help reduce the reliance on Earth-based shipments, ensuring that lunar colonies can maintain a stable supply of necessities even in the face of logistical challenges. The development of a comprehensive transportation network has further unified the lunar colonies. High-speed lunar trains now crisscross the moon's surface, connecting cities, research stations, and mining sites. These trains make travel across the harsh lunar terrain efficient and accessible for all colonists. Powering the moon's colonies and industries is a fusion power plant, providing a virtually limitless, clean energy source that enables lunar infrastructure and space exploration to expand without environmental constraints. This powerful energy source drives ongoing development on the moon, supporting everything from residential areas to industrial production facilities, and ensuring that lunar civilization has all the power it needs to thrive. In 2090, one of the most groundbreaking advancements is the implementation of a shared neural network, where colonists can connect their consciousness directly into a collective intelligence. This lunar hive mind enables individuals to communicate instantaneously, sharing thoughts, emotions, and information with remarkable clarity. This collective intelligence has fundamentally altered how decisions are made, allowing the entire community to function as a unified entity. Decisions that might have once taken hours or days to resolve are now addressed in moments, creating an efficient and harmonious lunar society that can tackle challenges together. Technological innovation has reached new heights with the development of self-replicating construction robots. Unlike traditional robots, these machines have the capability to produce copies of themselves, dramatically accelerating the building process. This self-replication means that once a few initial robots are deployed, they can quickly multiply, creating an entire workforce capable of constructing habitats, research facilities, and other essential infrastructure. As a result, new areas of the moon are being developed faster than ever before, allowing more people to settle and participate in the growing lunar community. In an effort to adapt to the harsh lunar environment and extend human lifespans, people are now transferring their minds into synthetic bodies. These synthetic forms are not only highly resilient to the moon's extreme conditions, but they also offer enhanced physical abilities, such as increased strength and durability, making life on the moon more sustainable for long-term colonization. The shift to synthetic bodies marks a profound evolution in human capability, allowing colonists to fully adapt to their environment and reduce the physical challenges associated with low gravity and radiation exposure. Equally revolutionary is the ability to transfer human consciousness directly from Earth to the moon using lasers. This technology allows individuals to inhabit synthetic or robotic bodies already stationed on the moon, bypassing the need for long and potentially hazardous space travel. By using lasers to transmit consciousness, the process of colonization becomes more accessible, enabling more people to experience lunar life without the logistical difficulties of a traditional journey. This leap in technology significantly enhances the moon's population growth, and opens up new possibilities for how humans might explore other parts of the solar system in the future. Moon colonization has taken a remarkable turn, with thousands of colonists expanding below the lunar surface, constructing vast underground cities. These subterranean habitats offer essential protection from harmful radiation and micrometeorites, providing a safe and sustainable environment where lunar civilization can flourish. These underground cities form an extensive network of interconnected colonies, designed not only for survival but also for a thriving community life. The underground structures support thousands of residents, with advanced life support systems, agricultural zones, and social spaces that make life on the moon increasingly self-sufficient and comfortable. Limited space on Earth has led to the moon becoming the host of vast data centers and supercomputers. Formerly isolated cave systems have been interconnected to create hyper-fast computer networks that span large portions of the lunar surface and subsurface. These data centers are crucial for powering global and interplanetary operations, providing the computing power needed to support everything from artificial intelligence research to managing the logistics of interstellar travel. Above the surface, the moon has become the center of humanity's expansion into the cosmos. Interstellar shipyards now serve as the primary hub for constructing massive spacecraft, taking full advantage of the moon's low gravity to launch enormous vessels more efficiently and cost-effectively than from Earth. These shipyards utilize raw materials mined directly from the lunar surface, creating a self-sustaining industry that powers humanity's ambitious space exploration agenda. The construction of interstellar ships on the moon is paving the way for missions to distant star systems, enabling humanity to expand its presence far beyond the solar system. Additionally, thousands of solar sails have been launched from the moon, propelled by powerful lasers stationed on the lunar surface. A hyperloop system now stretches across the lunar surface, connecting cities, research centers, and mining hubs. This high-speed transportation network allows colonists to travel between key locations in record time, making movement on the moon seamless and efficient. With hyperloop tubes connecting every major area, travel across the once inhospitable lunar landscape is as easy as taking a subway back on Earth, further solidifying the moon as a cohesive, thriving community. Massive domed cities stretch across the lunar surface, each housing millions of inhabitants. These domes provide fully self-sustaining ecosystems, offering everything from agriculture and energy production to social and cultural experiences. Particle accelerators have been built at a scale that far surpasses anything possible on Earth, enabling scientists to conduct experiments that push the boundaries of physics. These advanced accelerators are confirming profound scientific insights, first proposed by artificial superintelligences decades ago, expanding humanity's understanding of the universe and uncovering the fundamental laws of reality. The moon, with its lack of atmospheric interference, is the ideal place for such cutting-edge research, attracting the brightest minds from both Earth and other lunar colonies. The moon has also become a guardian of Earth's biodiversity. A massive vault containing the genetic material of every species on Earth has been established, ensuring that biodiversity is preserved in case of global catastrophes. This genetic vault is a safeguard for the future, allowing humanity the ability to restore ecosystems on Earth if necessary, or to potentially seed life on other planets. To protect critical infrastructure, advanced force fields are now deployed across key lunar facilities. These force fields provide protection from potential threats such as space debris, micrometeorites, and even hostile actions, ensuring the safety of the people and infrastructure that are vital to the moon's functioning. An asteroid defense system now spans the entire solar system. This expansive network uses sophisticated lasers and deflection technologies to protect not only the moon, but also other celestial colonies and spacecraft from the risk of asteroid collisions. This defense system is essential for the safety of the lunar colonies, infrastructure, and interstellar projects. With this level of protection, lunar society can thrive without the constant fear of catastrophic asteroid impacts, making the moon an even more attractive place for long-term human settlement and investment. Micro black holes are being used as both power sources and computational tools. These tiny black holes provide immense amounts of energy, essentially offering lunar colonies a nearly limitless power supply. The energy generated from these micro-black holes supports all aspects of life on the Moon, from everyday activities in lunar cities to powering complex industrial processes. Moreover, their unique properties have also allowed them to be used in advanced computation, pushing the boundaries of what is possible in data processing and quantum mechanics. The Moon has evolved into a fully independent world with its own identity, culture, and political structure. Governed by an intercolonial council, the Moon represents millions of inhabitants who have spent generations establishing a unique society that is distinct from Earth. This governing body creates laws and regulations specifically designed to suit the challenges and opportunities of lunar life, allowing the Moon to operate as a sovereign entity. A Stanford torus megastructure has been constructed in Earth's orbit. Similar to the one imagined in the movie Elysium, this massive space habitat provides a comfortable and self-sustaining environment for thousands of residents. It has become a hub for research, commerce, and leisure, serving as a bridge between Earth and the Moon. With advanced transportation systems, people now travel regularly between the Moon and this orbital megastructure, fostering an exchange of ideas, culture, and economic activity. Generations of humans born and raised on the Moon have begun to evolve physically, adapting to the Moon's lower gravity. These lunar humans have developed taller and leaner bodies compared to their Earth-born counterparts, as their physiology adjusts to the unique lunar environment. Over time, these adaptations have led to a divergence between lunar humans and those still living on Earth, giving rise to a distinct subspecies with its own customs, physical traits, and society. Perhaps the most ambitious project undertaken by the lunar civilization is the installation of a massive conductive counterweight on the far side of the Moon. This structure is designed to gradually pull the Moon and Earth away from the Sun over the course of billions of years. The goal of this long-term initiative is to ensure that when the Sun begins to expand, transforming into a red giant, the Moon and Earth will be pulled farther away, extending the lifespan of the biosphere and giving humanity a greater chance of survival. Advances in medical technology have also led to the extension of human lifespans to several centuries. This longevity allows individuals to live across various planets, space habitats, and outposts, experiencing different environments and lifestyles over their extended lives. Many long-lived humans have chosen the Moon as their home, viewing it as a key hub in their interplanetary journey. These centenarian settlers bring their wealth of experiences from across the cosmos to the Moon, contributing to the vibrant and evolving frontier of space. Thanks for watching. Make sure to watch this next video about space exploration.